guys, myself Himansu. I am studying computer science in MS Ramaya College. Today I am going to talk about elasticsearch. So let's start. So what is elasticsearch? Basically, Elasticsearch is an open source search engine that is built on top of Apache Lucene. It is a full text search engine library. Lucene is arguably the most advanced, high performance and fully featured search engine library in the existence today, both open source and proprietary. Elasticsearch is also written in Java and uses Lucene internally for all of its indexings and searchings, but it aims to make full text search easy by hiding the complexity of Lucene behind a simple, coherent and RESTful API. And more specifically, Elasticsearch is a standalone database server that takes data in and store it in a sophisticated formats that is optimized for language-based searches. So, and yeah, Elasticsearch is much more than just Lucene. So what is it? It is a distributed real-time document stores where every field is indexed and searchable. It is a distributed search engine with real-time analytics, and it is also capable of scaling to hundreds of server and petabytes of structured and unstructured data. So basically what it does is it store the data on node that is called server in Elasticsearch in a horizontal phases. All the nodes are scaling in a horizontal way that is best suited for indexing, and it is also retrieve the results very fast. So let's talk about what are all the features of the Elasticsearch. Basically, we can say that it is a real-time data search and it is real-time analytics. It means that we can use for log search or log search and product catalog, and it is distributed and it has high availability. It means that it's replicate all the data in multiple servers, and it is multi-tenancy. As we told, it is a full text search engines, and more specifically it is a schema free. It means that we can store any type of we can store text, or we can store book, or we can store any story on anything. And communications, basically we can provide communication with the server using RESTful API. So what problem does Elasticsearch solve well? Right, we are studying Elasticsearch, so we have to know use cases of the Elasticsearch. So basically you can run, suppose you want to create an e-commerce website, so you can run an online web store where you allow your customer to search for products that you sell. You can use Elasticsearch to store your entire product catalog and inventory and provide search and autocomplete suggestions for them. You can run a price alerting platform which allows price savvy customer to specify a rule like I am interested in buying a specific electronic gadget and I want to be notified if the place of price call falls below or is falls up from any vendor within next months. So in this case you can use Elasticsearch, and you can also use for collect logs or transaction data, and if you want to analyze that transactions and mine this data to look for trends like statics, summarizations or anomalies. In this case you can use log stacks, that is part of Elasticsearch and Kibana stacks, to collect aggregate, and you can parse your data and then have log stacks feed this data into Elasticsearch. Once the data is in Elasticsearch, you can run searches and aggregation to mine any information that is of interest to you, and you can create your own dashboards using Kibana, or you can visualize your all the logs data in the dashboards. You can also have analytics, business intelligence need, and want to quickly investigate, analyze, visualize, and ask as order questions on a lot of data. In this case, you can use Elasticsearch to store your data and then use Kibana to build custom dashboards that can visualize aspects of your data that are important to you. Additionally, you can use Elasticsearch aggregation functionality to perform complex business intelligence query against your data, because it provides a very good query language that is called DSL. In that, many operations like aggregations and filtering, everything is available. So let's talk about in which cases the Elasticsearch is not good. Like suppose I want to calculate how many items are left in my inventory. In that case, the Elasticsearch query language is not good, and we can also say that like figuring out sum of all the line items on all the invoice sent out in a given month, or executing two operations transactionally with rollback support, or creating records that are guaranteed to be unique across multiple given terms. For instance, let's take a phone number and its extensions. So Elasticsearch is generally fantastic at providing approximate answers from data, such as scoring the results by quality, but Elasticsearch can perform exact matching and statistical calculation. Its primary task of search is an inherently approximate task. So let's install Elasticsearch. So first we have to know what is prerequisite for installing Elasticsearch. So you must have Java version, because to run the Elasticsearch we have Java, and because it's written in Java, so Java is required for running the Elasticsearch. So first check whether Java is present or not in your system. So for that, type command java minus versions. So it's already installed in my systems. If you don't have, so first update your OpenJDK with apt. Like type sudo apt get update. After that, you can install Java using sudo apt get install OpenJDK 7 JRE. After that, you can verify your installation using Java minus versions. Okay, so let's talk about how to install Elasticsearch on your machines. Well, frankly speaking, Elasticsearch can be downloaded directly from Elastic Code in zip, tar.dz, deb, or rpm package. But for Ubuntu, I'll suggest the best is the Debian package, which you will install everything you need to run Elasticsearch. So let's type command to get Elasticsearch on your machines. So type wget https://download.elastic.co/elasticsearch/elasticsearch/elasticsearch minus 1.7.2.deb and press enter. After that, you can see your download will be in progress. Since I already installed in my systems, so I don't want to install again. Then install it in usual Ubuntu way with the dkpkz package commands like sudo dpkz -i elasticsearch -1.7.2.dev and press enter. It will ask password, so type your Ubuntu machine password. Okay, so it's running reading databases. Fantastic. So that's Elasticsearch is installed now. Now we have to start our Elasticsearch machines. You can name your Elasticsearch in elasticsearch.yml file that will be present in etc/elasticsearch/elasticsearch.yml file. In there you can set your number of shards or number of replica or path of data or whatever you want to security. So type how to start the Elasticsearch servers. So type command sudo service elasticsearch start. After that you will see the message. It's Elasticsearch servers already running. Okay, so how to check whether the server is running or not? For that we can use a curl command, or we can use any RESTful API to check whether the server is running or not. So let's check out how to check. So type curl -x get http://localhost, which is running your machines, port number that run Elasticsearch on 9200 port numbers, and press enter. You will see a message prompt message. So since it's taking a long time, I don't know why, but it will send a message. Okay, it's taking too much long time. Failed to connect to port 1080. Connection default. Sorry. Let's try again and press. Sorry, my bad. That is capital X. Sorry, my bad. Type again. Curl -x. This is capital X and get and press enter. You will see their prompt message, that is status 200. Your name is Zarela. Your cluster name is Elasticsearch, and the versions 1.7.2 build has and everything, and it's also showing the Lucian's versions. So what do we want to do now? Now our Elasticsearch is installed and it's running, and we can see we are getting the message from the Elasticsearch. So what we have to do? So now we will perform CRUD operations on Elasticsearch. So how to perform CRUD operations? For that, so in order to perform CRUD operation, we have to first index our documents. So how will we index our documents? So in order to index our JSON object, we make a put request to the REST API to a URL made up of the index name, type name, and ID, that is HTTP localhost, port number, your index name, your type, and you can specify ID. The index name is arbitrary. If there is not an index, with that name on the server already. One will be created using default configurations. But as per the type name, its two is arbitrary. It serves several purposes, including each type has its own ID, a space, right? Different types can have different mapping. Although it is possible and common to search over multiple types, but it's easy to search only for one or more specific type. So I am using Postman REST API to index our documents. So let's use Postmans. So let's check it out. Postman is basically Google Pro, that is fully RESTful API. So let's check it out whether it's getting message from the Elasticsearch or not. So for that, just type get methods http://localhost:9200 and press send. So it's coming again the same result. The status 200. It means it's fine. It's getting data from the Elasticsearch. Name is Zarilla. Cluster name is Elasticsearch. So everything whatever is there in the call command, we are getting the same message. So let's now perform CRUD operations. So for that we have to put data in the Elasticsearch. So let's put data. So let's suppose our index name is like create Holly movies index data. So let's type the index name as Hollywood and movies, and the ID is once. If you don't specify ID, it will automatically create our ID, that is will be unique. So let's export. So go to bodies, press shut. So it's telling index Hollywood movie false, ID 1 version 2 created false because I already created this index. So let's try another ones. Let's type ID 2 post command. Post URL where index name is Hollywood and the type is movies and the ID is 2. So let's post some information. So basically it's take this data in JSON format. So select the application.json and type your information. So let's type title, as let's take out the Godfather movie. Then we want one more information like director. Who's the director? The Godfather. Francis Ford. Let's create one more field that's called year. Let's call 1970. then press send. So as you see, there is a message called index Hollywood type movies id equal to 2 version true and created true. It means that we created our index, that is this informations, and it's true. So let's put one more data. No good further, let's type let's take any other movie like ABC and the director. XYZ. Press sure. Again it's coming true, means it puts the data in the elasticsearch. So what now? So let's populate some O5 data and that. Let's type fantastic, it's creating. So now we populate data into the elasticsearch. Now it's time to check how to get our movie, right? Like we perform put operations, create operations. So now let's retrieve our data from the elasticsearch. So how will you retrieve, right? So for retrieving, instead of put, we use get. So go to there, select method get, then what movie information you want to like. Want to select movie 1. I'll send the information. See, it's getting our data. Index name is Hollywood, type movies, ID 1, version 2, on true, it means there, then it's containing all the data whatever we mentioned in the source field. The source is title Titanic, actor Leonardo DiCaprio, year 1990s. So let's perform for index suppose 2, The Godfather, whatever we created, the classic movie. Yes, we get the fantastic Hollywood movies and editing. So we perform get put. Now it's time to modify our. So let's perform. For modify we use put operations, right? Because post will post new message, it won't update the previous result. So let's use put. So suppose I want to change the movies for, and in that I want to add one more field like generation, right? Generation. And then like where is this drama, we can perform many. We are posting less, like it's drama. It's so let's type drama, or we can say finance planning also love story. created, so it's updated result. So how will we check whether the result is updated or not? So for that we again use get, right? It is for, so yeah, we are getting updated results. It's updating our result. Before that the genders field wasn't there, but now it's updated the genders fields like genres, drama, love story. So we perform crud operations, but we didn't perform delete operation. So how to perform delete operation, right? So performing crud we used to use delete operation. So for delete, select methods, delete movies, whatever ID you want to mention. I want to mention suppose I want to delete Titanic movie data. So let's, Titanic movie ID is 1, so then press enter. It's coming right, found it true, it means it deleted that documents. So let's check again whether it's there or not. Get, so it's coming false, it means that movie details is not there. That in ID detail no information is present. If any information is present, that will comes in the source field, but here no information is present, so it's coming no source fields. Yes, so we perform crud operations, normal crud operation on elasticsearch. So let's talk about how to search, right? So we have covered all the crud operations. So how do we, if I want to search, like how I want to search point? So for that, no need to all that. No need to, suppose I want to get whole document, whatever the data is present in my Elasticsearch. So for that, I'll use http localhost 9200 / search method, right? If I use search and I'll press send, I'll get a whole lot of data, right? See, we are getting all the informations whatever we push till now. So in that it's telling total 220 times, timeout is false. So see, in every header we have our data that is present in list. This is the one movie that ID is 4, then ID 2 movie informations, then ID 3 movie information, and we deleted ID 1 movie information. So we getting, so till now we perform CRUD operation in Elasticsearch. Now I'm going to talk about what we must do in Elasticsearch. So first, least or not the least, first we must have to change cluster name, and then we must have use aliases and keep all nodes in same subnet. Use unicast discovery and 1G 10G connectivity. Have enough memory for JMP heaps. Tune kernel parameters for user processes file network limit, and least or not always check for JVM version compatibility. Also stick to Oracle JVMs. Avoid running Elasticsearch along with another service on the same box, and avoid vertical scaling because horizontal scaling is the best because it's distribute the whole lot of bunch of data in different nodes, and when we perform query we will get the data very fast. And don't allow unrestricted unsupervised querying unless you know the user base, and never send data for indexing or search query to master nodes. Now I'll talk about tips for indexing. bulk indexing with reference interval set it to -1 and send it directly to data nodes, and set aside more resources for bulk thread pools. Build new index per month, per week, per day, per hour, and use aliases to secure your data. And decide the temporal splitting and number of shards replica based on your volume so that we can perform very fast query and increase our throughput. And slight performance gain when using raw TCP over HTTP. If getting timeouts, try increasing the timeout in doubles. Don't use a lot of types in a single index. Always divide your documents according to index and types. Always use mapping templates for predefining fields, and disables all fields unless readily needed. Know which fields not to index. Decide which analyzer token filter work best. So till now we did basic Elasticsearch, we performed crud operations, we performed tips for indexings, we did tips for indexings, and in the next lecture I am going to talk about query DS cells. For that time, like my video, subscribe, and if you have any problems, comment on below. I will solve possibles. So till now, bye bye.